right, we're going to talk about and use the sum and difference formulas. So, you know, instead of going through the proofs, there's actually a proof in your textbook. It's in Appendix A. It's very easy to follow using just geometric properties, but we're not going to spend the time to do that in the video here. But if you're curious, go ahead and take a look at that. But notice here we have the sine of A plus B, the sine of A minus B, so sum and difference. Cosine of A plus B, cosine of A minus B, and same with tangent. So you will need to know these. More importantly, you'll need to understand these and know how to apply them to problems. So that's really what we're going to be practicing here. You know, if you take some time and kind of look at them, you can see these trends, right? So I would just take time and let this sink in. Now, let's look at these two problems. It says find the exact value of each of these. We have sine of 3 pi over 4 plus sine of 5 pi over 6. And then we have sine of 3 pi over 4 plus 5 pi over 6. Notice that these are two different expressions here. They are not asking for the same thing. You won't get the same thing, in fact. So what I'd like you to do is for this first one, you guys should totally be able to do this. This one is simple. I'd like you to find the exact value of this sum. Over here, I'd like you to use the identity, which you have right above in your notes. Use the sum identity for sine, and then you should be able to come up with an answer. Now, one thing I just want to point out here, sometimes when people see things like this, they're like, oh, just distribute the sign. You can't distribute a trig function, okay? So that's not a thing. It's not like sine is a number where it's like 4, distribute the 4. No, sine is a function. It's a function of something. Also, just keep in mind that this really is sine of 19 pi over 12. So, you know, it's sine of a quantity, sine of a number. So go ahead, put me on pause. I'll stop talking. Okay, so for this sum here, we get the root 2 plus 1 over 2. And then for this one, where we actually have to use the sum identity for sine, we actually get negative root 6 minus root 2 all over 4. So clearly, these are different. Okay, so what's the point? Is this just plugging in numbers? You know, obviously, we are following this pattern, and it's a way, and eventually when we're doing more simplifying and solving, you know, these might be easier for us to manipulate and change the original equation using important identities. So yeah, just that practice was plugging in numbers truly, but we'll use this in a more complex way. Duh. Here, let's see why this could be important. So I have negative 7 pi over 12. So it says find the exact value of the sine, cosine, and tangent of. So here's an example where this identity will be useful, the sum or difference identity, instead of just plugging in numbers. So how could we find this exact value of something like this? So first and foremost, note that you have options, right? Because there's a bunch of ways that we could find a sum that equals this or a difference that equals this. So let's see what you guys can come up with on your own. Okay, so there's gonna be a lot of work for this one. Make sure you guys save room on your paper for space. All right, go ahead, put me on pause. All right, boy, was that a doozy. That was a long problem. I just wanted to show what I was talking about in the beginning here. Maybe I should have the rest from you so you don't get distracted. It's more for me, actually. You know, we could write negative 7 pi over 12 in two ways. I could write it as the difference of pi over 6 minus 3 pi over 4. I could also write it as the difference of pi over 4 minus 5 pi over 6. So either way, you should get the same thing. But again, I just wanted to let you know that you have options. So we were trying to find the sine, cosine, and tangent of this value. So with the sine, I used the difference pi over 6 minus 3 pi over 4. Plugged everything in. I got negative root 2 minus root 6 over 4. Hopefully you got the same. Let's just get rid of it. For cosine, I did the same thing, and I got negative root 6 plus root 2 all over 4. And then tangent's the one that kind of made my head hurt a little bit, maybe yours too, but I mean, it was fun, like a good head hurt, you know. You know what I'm talking about. That's the good kind of brain work. Anyway, so same thing here. I plug things in. Now, when I get to this point, I'm trying to clear out these denominators, so I multiply the numerator and denominator by 3, and then I get this guy. And I'm like, shoot, well, now I have a radical in my denominator. I gotta multiply by the conjugate, so then I get there, and I'm like, shoot, I gotta simplify the numerator. So then I did that, and I was like, shoot, all these are divisible by 6. So finally, I got to 2 plus root 3. Now, you might be thinking in your head that there were root 6 and root 4, or sorry, root 2 and then 4, and then all these things came up and they were all common, and you might be wondering, is that supposed to happen? You will find root 6 and root 2 and even 4 come up a lot. The order and signs may vary, but you know, you will see that happen. Okay. Next one, it says write the expression as the sine, cosine, or tangent of an angle. Okay, you can do this. All right, go ahead, put me on pause. Okay, so I was just kind of looking at the pattern and then looking at my sum and difference identities, and I just kind of recognized right away that this looks like the sum of sine identity. So then it's the sine of 4 pi over 9 plus pi over 8. Which I can actually combine those two together, and I got the sine of 41 pi over 72. Okay, next one. It says, find the sine of u minus v, given that u and v are in quadrant 2, and that the sine of u is 5 over 13, and the cosine of v is negative 4 over 5. Now you might be thinking, why is this important? Why are we going to use this at all? So my hint is draw a triangle for u, draw a separate triangle for angle V, and then perhaps that should help you. Go ahead, put me on pause. Okay, so I told you guys to draw a triangle, so hopefully you did that both in quadrant 2, because that's what the directions tell you, and you can figure out the third side. So then sine of u minus v, I'm using the difference identity for sine. I should get a final answer of 16 over 65. Great, let's look at the next one. It says, write the trig expression as an algebraic expression. Okay, so in other words, we want just, no trig in our final answer, so let's simplify. Okay, hint, this also will involve using triangles. So yeah, let's see what you guys can come up with. I think you can do it. Okay, so go ahead, put me on pause and try this one on your own. Also, hint, this is going to be using the difference identity for cosine. All right, hopefully you found that this one wasn't as bad as it might seem. So again, I gave you a hint that you're going to be using the difference identity for cosine and to draw two triangles. So I drew a triangle for cosine of theta being x over 1. Here's what that looks like. For this one here, instead of using theta, because I want to use something else, I use beta. The sine of beta is x over 1, so here's that triangle. Now, here's where I use that difference identity. So I have cosine arc cosine of x, that's cosine of arc sine of x, sine of arc cosine of x, times sine of arc sine of x. Here, this is just x. The cosine of the arc sine of x, so the cosine of beta is square root of 1 minus x squared, plus this here is the sine of theta, right? So that's square root of 1 minus x squared, and then this is just x, which is 2x square root of 1 minus x squared. Next example. Verify the identity. Remember, we're not solving, we're verifying, okay? I'll give you a hint. I would start with the left side. Remember, we start with the complicated side. And also a hint is you probably want to use your difference identity. Okay, go ahead, put me on pause, try it out. Okay, so we use the difference identity here for sine. So I did that. Now, sine of 3 pi is 0. Also note that this cosine of 3x, which really not x, that should be a pi. I'm sorry, guys. The cosine of 3 pi is -1. So this obviously is going to go to 0. I have the opposite of -1 sine of x, which is sine of x. So therefore, I just verified the identity. Okay. This one, we are going to solve the equation. We want to solve it between 0 and 2 pi. Okay? So let's see what you guys can come up with. Now, where to even begin this one? I know this one looks a little bit crazy. I would start by using your sum identity and then your difference identity. Okay, so we're just going to expand and hopefully that will condense to something that we can actually solve for x. Go ahead, put me on pause. All right, so I expanded this. So I used the sum identity for cosine here, and then I also used the difference identity for cosine here. Now, something to note here, I know that this is minus, and then this would be an addition, but I did distribute the negative right away, so I just want you guys to know where that went. Now here, these terms are going to cancel out, so now I'm left with -2 sine of x sine of pi over 6. Sine of pi over 6 is 1/2, so those cancel out here. So you get sine of x is -1, and the only solution between 0 and 2 pi is 3 pi over 2. Okay, so in conclusion, just know the sum and difference formulas, know and more so understand how to apply them. All right, great job.